Hello everyone, January 30th. Alright, let's get on to it. Oh, that's the polish notation. Evaluate it. An array of string tokens represent an arithmetic. Evaluate. Return integer represents. Okay, Polish. Each operand may be. Hey, good morning. No, it's probably not morning for you. Each operand may be an integer or another expression. Division between two. The division between two integers always truncates towards 0. Okay. Will not be any division by 0. Input represents a valid. Okay. What's Polish? It's a stack, right? 2, 1 plus 3. And then 2, 1 plus. And whatever this is, this and the 3 and 2 multiply. And this 4, 13, 5, this. 4, 13, 5, this. Oh yeah, whenever you hit a operator, you pop two values out. You do it, you push it in, and yeah, I think that's the one. So 13 divided by 5, I think it's 2, right? Okay. All right, let's do this. What question do you have? All right, let's do this. So we need a stack. I remember. Okay, so we also need operators. Ooh, operators. I think. Can we do this? Import operator. I'm not sure. Operator. Yeah, I think we have operator. Can we do operator dot add? Yes. Minus. Can we do operator dot minus? Dot deduct? Huh? What's minus? Add. I have no idea. Add. Oh, sub. Must be sub. Yes. This must be operator dot mult. And operator dot. Oh, they have divide though. I'm not sure. I am not sure. Operator divide. True div. floor div. Okay, I guess we have to use the floor div. Yeah, that's the one. Okay, so we have this. Now we for t in tokens, right? If t is not in operators, right? And then we say stack dot append t, else we'll pop two values out, right? And it says it's always valid. Is it valid? Okay, so we'll pop two. So we'll say stack dot append operator t. It's a function. I want to call this function on stack dot you know what, I'm going to say a equal to stack dot pop, right? And stack dot pop, and this is going to be a and b. So b is the first one popped, and then we're going to push this in, and at the end we shall just return stack 0, because at the end it should only have one value. Oh, operators. There's some error because this return is not. Oh yeah, I didn't close it. There we go. Okay. Oh no, I didn't. Shoot. Forgot, and then turn it into integer. Which one? The last one. Oh, of course. Wait, hold a second. That's the token of the entire thing, right? Why is it not right? Okay, hold on. 10 plus. 3 plus. I'm getting 12. 10. Oh, I see. I see why I need to keep going, right? So as I go through, I get all the tokens, right? I get all the tokens, but but shouldn't the last one coming in? That's weird. I think what I have is at the end, it's just not over. We can actually do this. We can print stack at the end, and we'll see that there is still stuff in the stack that it was not completely done yet. Strange. Eval tokens. Okay, let's. 12. Ah, it is 12. That is weird. That is weird. Huh. Okay, let's print it out. Let's see what each one is doing. Okay, so we can just print AB and token. AB and T. Okay, so we have 93 plus, and then 12 minus 11 multiply, and then 6 probably is this one. 6 divided by minus 123. That should be a 0. That should be a 0. But oh, a floor division. That's the divide. Damn it. Interesting. So this is, yeah, floor division, a little bit flawed. Okay, so we need to, so basically if they are, so we need to do absolute value first, okay? And then after absolute value, then we need to do, so basically we can do, let's say lambda AB, okay? Then we shall do absolute division of A and B, and then we shall apply times okay, so we'll do this. I should do this. We say ABS A divided by ABS B multiplied by 1 if A times B is larger or equal to 0, else minus 1. Alright, just kind of rewrite this. There we go. That's the error. Okay, 50K. Are they in company or company you're working in can provide? Yeah, I think the company I'm working in, it's pretty good. ServiceNow. ServiceNow is really it's a good place to be. They do have, I mean, like for me at least, I'm a hybrid. Oh, you gotta be kidding me. What the hell? Yeah, I'd recommend ServiceNow. And I think they're still hiring. They're always hiring. The company is expanding, so. Yeah, I think ServiceNow, you'll have opportunities in ServiceNow. I mean, the interview I went through is not that bad. Honestly, it's not that bad. Oh shoot, it's integer. Damn. Wow, these little edge cases. Remote, I mean, they have remote option, but if you just got high, you know what, it depends. Remote is a big thing. Like I mean, like in my team right now is, I think at least 3 or 4 people are remote. So it's not like something unheard of. It's you can definitely remote in ServiceNow. Division, because the Python default floor division works differently with negative values. Okay, so this one's good. I'll take a look. I'm not sure if they have, but they should, right? They should have referral. I'll take a look. I'll get back to you. Yes, without space. And a capitalized S and a capitalized N. I think that's how they write it. Yeah, it's a pretty big company. It's a pretty big company in a very niche enterprise software area. It's been around for a while. Well, expect general coding capabilities. Everything ServiceNow is a platform. It's a platform for big companies to run their, let's say, customer service management or anything. And they have their own platform, which means they do the things their own way. And depending on what team you're on, like if you are on the platform team, you need to know Java, like a lot of Java, because everything backend and server side is written in Java. But if you are in the application team, yeah, a little bit JavaScript, but mainly is the willingness to learn their system. Their platform is huge. It's huge. It's a very vast system. So you need to be willing to really dig into it. And then they do things very differently. Yeah, hands-on experience with JavaScript is more than enough to if you go for the platform the application team in ServiceNow. That's more than enough. Yeah, just you can take a look. I'll take a look. You can take a look as well. I mean, I've seen people getting hired, constantly getting hired because again, like the company is growing, it's still growing. It sounds weird. It's like it's a 20-year, it's more than 20-year-old company, but it's still growing. Yeah, I say give it. I say give it a shot. The because I'm in the application team, which is pretty it's not that hard, I think, to get in. Platform team with Java stuff, not quite sure. I don't know like how difficult it is. Yeah, I can send you a resume. I'll take a look inside, see if I can get a referral for you. And you should all definitely try it yourself as well. Yeah, it's like one of those niche company that, not on a lot of people's radar, but it's good. At least on the US side, it's very good in the company culture, and I quite enjoy it. I'm not quite sure how on the Indian side. I'm not sure. I'm not sure. Hey, I was a new hire, so I don't think I have too much to say whether a person can join. But we did add. I mean, since I joined, our team add. I mean, I was a new hire 3 months ago, and in that round we hired 3 people, and after that we hired one more. Like after a month we have one more, and I heard yesterday that we just hired one more, so it's like in the span of 3 months we hired 5. Yeah, I'll ask around. All right, we're gonna go back to this one. This is K-inverse pairs. So we solved it. I don't remember. How did I do it? So I have the DP in the original, but I think I have a better solution here. Yeah, that's a good mentality to have. All right. Pre-K is the exact number of ways to produce K inverse pairs. And I have this, so this is the number of rows, right? You can think of it as number of rows, which the rows represent up into the length. Okay, the length. So we start from the length is 1, and we have 0 pairs. Okay, that makes sense. And then we go through I, so we have, this is 2, right? The length is 2. The length is 2. And always 0 pair is 1, okay? Now we're gonna go through K. So we say we want 1 pair, 2 pairs, all the way down. So the number of pairs for the current, will equal to that is interesting. The previous number of pairs. Okay, what is this previous number of pairs? So up until the previous, we have a total number of pairs that we have with, so let's say we're thinking about 3, right? We want to know length is 3, how many pairs are in it, okay? Then we look into length is 2, okay? Look into length is 2, how many inverse pairs in length is 2? That is correct, because if you have length of 3, and the total number of inverse pairs shall include the length of 2. And now you add one more value to it, right? One more value to it. Then what you want to know is the previous, no, hold on. That is not, that is length of 3 with 2 pairs. That is length of 3 with 2 pairs, my bad. Length of 3 with 2 pairs, right? With 2 inverse pairs. Wait, hold on. What is K again? I got confused. Blah, blah, blah. Exactly the number of different array consisting of exactly K. Okay, so it's the number of different arrays with the previous, right? K minus 1 pairs. And what we'll do is, wait, why does this one matter? So we're trying to find 3 pairs, and then we go back, say, okay, we have 2 pairs, right? Length of current length, but I want to find 2 pairs, okay? So previous with 2 pairs, then we just need to add one more pair. Maybe that is the idea, right? So we have the previous pair, we just need to add one more pair. But we can also consider this. Okay, what is this? What is this? This is pre-J minus, so J minus 1, my god, J minus 1 larger or equal to I minus 1. Okay, J minus 1 larger or equal to I minus 1. That's the number of pairs if it's larger or equal to I minus 1 is the length, right? We say if that is larger than the length, then we do J minus 1 minus I minus 1. We have to read this again. So for current K minus 1, we have current K minus 1 equals So current k minus 1 is, given the current length, we want to go k minus 1 number of pairs. And to do that, it is essentially the previous. Oh, that makes sense, right? That makes sense. Given a current length, and I want to know a certain number of pairs, right? I want to know the certain number of pairs. And it's equivalent to ask the previous, is without the current, right? Without the current number, not with the current number, the previous on k minus 1 pairs up into this position. Not up into this position. Pre is with a lower length. Wait, does that make sense? Hold on. So let's say we have something, 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 right? I want to know the number, I want to know the number of k inverse pairs, okay? Inverse pairs in this array. And to do that, I say, how about I know the number of k inverse pairs in this? Okay, that makes sense. Number of k inverse pairs in this. But aren't they overlapping? I would say that number of k inverse pairs. Morning. Looking great. How do you feel? You sleep? Yeah, I saw your resume. I got the email. All right. I don't understand this one. Why current k minus 1 is equal to these added together? Why do we add these together? Huh. We say current k, which is current length, right? Current length gave me k. It will be the previous length, which is this. Oh, the previous length is not doing this way, my bad. It's the previous length, this give me k pairs. How many different ways I can get k pairs? Or how many different ways we can get k minus 1 pair? How k minus 1 pair? Wait, hold on, let me read it one more time. Two integers, right? An inverse pair. Okay, so we say the number of different arrays consisting of numbers from 1 to n such that there are exactly k inverse pairs. K inverse pairs. So I want to know how many k inverse pairs are here. So I say yes, I will find how many k minus 1 inverse pairs is in the previous, because that can be extended here. But what does pre k minus 1 do? Well, so how many k minus 1 inverse pairs in the previous, right? And how does that help? See, that I don't understand. K minus... is not a cumulative sum, but the exact number of ways to produce k pairs. Then for current k minus 1, we have current k minus 1 equal to pre k minus 1 plus pre k minus 2. I am not sure what this means. Right, this is the current. Number of ways to create a J or fewer. Create J or fewer inverse pairs. Huh. But this is not. Right, this is not. This is said is not a cumulative sum, but the exact number of ways to produce. So why would this work? All right, let's do it one by one. Right, so pre-0. No, but k, so pre, we start from, doesn't matter. Right, let's start from 1. And then current, which is current length, we get 1. How many? Well, do 0 and plus. Yeah, this I don't know. They just add all these together. That doesn't make any sense. What the hell? What are we trying to do here? Current J minus 1. What's current J minus 1? Is, so current J minus 1 is the number of arrays to make J minus 1 inverse pairs, right? Inverse pairs. Okay, so I know that. That's J minus 1 inverse pair. Now I want to make J inverse pairs, which means we need one more, right? We need one more inverse pairs. Then we say, now this is coming from here. I probably need, I don't know. Okay, I need to read the 2020. I need to read the previous. Maybe I have explanation here. There is no explanation. Come on, man. Okay, this seems to be an explanation. Okay, the king said that if we know the total number of ways to form k inverse pairs with n numbers, that is not even a sentence. We want to add n plus 1. If we add it at the end, then n plus 1 number with k inverse has the same number of ways as n number with k inverse pairs. We can say this is equal to this. Wait a second. If we add n plus 1, which is the largest value, if we add it at the end, then we have the same. Okay, I agree. This is right. If we shift, oh, that's the trick. If we shift this number one position to the left, then it already has one more inverse pair. That is correct. This means by shifting n plus 1 one position leftward, we can achieve k inverse pairs in dp n k minus 1 ways. That is correct, right? If we shifted 1 to the left, we will have produced one more pair because n plus 1 is the largest so far. So we shift left, we already created one pair. So in total, we only need to know what is the k minus 1 way and add one pair. And then we keep going, and then we keep going, and we keep going. Oh my god. That is way too smart. That is way too smart. Come on, I cannot handle this. Oh. And then another way is, yeah, we agreed on this on the pre. I mean, what we agreed on is current shall equal to, no, that's not what we agree on. We agree on is this. Right, we agreed on is this. Right, so every time you do, you go find the previous length. So we agreed on these two, we agreed on. And we want to find this. So we say, oh, dude, yeah, these two, if we minus, oh my god. Okay. All right, so the key insight, my god, is this one of the, I think this is the, you know what, we need to do this. Maybe not 30, 20, hold on, 20, 28, 29, my queue, number submetric task, 29, 20, 27, K inverse pair, there we go. We're gonna go down. All right, let's redo this. All right, so let's get insight. This is the good solution. Originally from the 2021, right? Now I think the explanation is here. This is the explanation. 2021 and 2022. From the 2022 solution. All right, so the idea, right? The idea is that we have dpn or dpij, okay, dpi j equal to the total number of arrays with length I that can make j number of inverse pairs. Okay. We also require that we only use numbers 1 to I to create to form these arrays, right? Now we want to compute. Now we want to compute dp I plus 1, and is I plus 1 j plus 1, right? I plus 1. No, we can say I. Now we want to do, wait, hold on, is it I or I plus 1? Wait, this is I the length, right? We add a new one. and we want to find the same. Yeah. So we add a new one. We want to compute this. Okay, we want to compute this. Compute this. We can say we can add a new number, I plus 1 to the array. Now I plus 1 is the largest number. Thus if we add I plus 1 to the end of the previous array, we will we just add 2 to the end, not the previous array, just to the end. Then we will have dp I j, right, number of inverse pairs, right? We'll have number of inverse pairs in the new length, array length of I plus 1. If we shift I plus 1 position to the left, we will have an additional inverse pair. Thus, the number of arrays, right? Arrays to make J inverse pairs is dp, well, I minus 1, right? I minus 1 J minus 1, because the length gets smaller. The length gets smaller, right? The length gets smaller. That's not true. Hold on. I minus 1. Well, we're doing I. We're doing I. Hold on. We're doing I plus 1, right? So if we put the last one, it will be this. If we shift it forward, if we shift it forward, it doesn't really matter, because it doesn't matter. Well, what? Yeah, it doesn't matter. So it does not matter. So first of all, it's not I minus 1, right? It doesn't matter. So if we shift this I plus 1 position to the left, right? So we add it. That's a new one. We add it in. Then we'll naturally produce a new pair. Right? We'll naturally produce a new pair. So it's whatever the previous pair I can produce, and we'll always add 1. That's the number we have in addition. That's the number of array to make J inverse will be the previous with J minus 1. That makes sense, right? If we shift I plus 1 2 positions to the left, we will have 2 additional inverse pairs. Thus, we need dp I j minus 2, right, from the previous dp value, right, to satisfy the current need. So on and so forth. We can write dp I plus 1, right, I plus 1 and j equal to what? I plus 1 and j will equal to dp I j, right, plus dp I j minus 1 plus dp I j minus 2 plus plus dp. Okay, we need to figure out what is the end for this. Well, we keep going until we hit until we hit a point where we cannot go anymore. Is that just hit to 1? I don't think it's hit to 1, right? It's hit to 0. It's hit to 0. It's hit to 0. Because it doesn't say you hit to 0 though. K minus n. Ah. It depends. The max we can go backwards, right? The max we can go backwards. Okay, J is the number of pairs, right? J is the number of pairs. So we can hit the 0, or what is K minus n? K is the total number of pairs, right? The total number of pairs. If you want a gigantic number of pairs, and then your current length is not enough. Wait, how do we understand this part? Right? You're saying we have current K is the number of pairs, right? We want however number of pairs. And we're decrementing up until a point where, let's say K is 3. So we want 3 pairs. And N is a length. N is 2. Okay, N is 2. Now K is 3, N is 2. That's actually not possible. N is 3, K is 2. You want 3 pairs out of a length of 2. K minus n. K minus n. Well, this just means if K is larger than n, how would K be larger than n though? Right, K can be larger than n, right? K inverse pairs. Example. Now here K is not larger than. What would be happen? Like if I have n equal to 3, K equal to 4. N equal to 3, we want 4 pairs. Alright, we want 4 pairs. Oh, there could be 4 pairs because we have, 3 to 1, right? 3 to 1. 3 to 1 has like 6 pairs. Right, 1, 2, no, 3 to 1. No, it's at most. Okay, I have the last piece. It's kind of struggling. How many pairs does this have? All right, I have 1 pair, 2 pair, at most 3 pairs. So why do we do this K minus n stuff? Huh? Why do we do this K minus n? Because you might hit, right? You might hit. And that shall be a 0. If your K is larger. If K is larger than n, shouldn't that just be a 0? What does this one say? This one just say maximum. this one just say maximum. All right, this ending condition is really troubling me right now. All right, so we can add from here, and then we can go, right? It's the j with the same length, because I'm moving my position to the left. So I have, you know, certain number of pairs, and I move again, and I move again. At a certain point, I'll hit 0. Right, I'll hit 0. Why can't I just do this? Right, why can't I just do this? Why do I have to compare I plus 1 and j? Why? Why? Okay, yeah, I agree. Position. This means shifting position left, we can achieve K inverse pairs in this number of ways. If we shift left 2, we can achieve, yes, we can shift 3, get a certain point. Because at most we can shift it n positions, right? And most we can shift n positions depending on the length, right? We can shift n positions. So depending on the length of n, if k is big, right? If k is big, but still, k is not gonna be, k will be, right? K will be, because the way that we run this, k will be bigger than n. Then we will hit a k that is humongous, right? And then we have a small I, and we basically just say, don't go more than, man, that, yeah, I guess it makes sense, right? I guess it makes sense. Because this is the number of ways we shift to the left. Basically, we just say, if we have a small k, right? Yeah, because we need to do k minus n. All right, that makes sense. We need to do k minus n. But we want, k is usually larger than n, but at a certain point, sometimes k will be small. Yeah, it's, okay, this is to handle when k is small, right? When k is small. So when k is small, we don't want it to go to the negative. That's it. It's not about k larger than n. K cannot be larger than n. It's when k is small, right? Okay, like we say k is equal to 1 and n is huge, right? And then when we do that, we just want it to go down to 0. Okay, now that makes sense. It is go down to 0, but it is go down to 0, but it's a little bit, so we need to do maximum, right? It's maximum I is the length, because it's I minus j, yes, and 0. So we want this to end at 0, right? Now, if we do this in 1DDP, we can call current j, right? And call current j for the I plus 1, for the length, right, of I plus 1, and pre j, right, for the length of I. Then we can say current j shall equal to pre j, right, plus pre j minus 1 plus pre j minus 2 plus plus pre maximum j j minus, because you need to move back how many times? As a dpi, right? So it'll be I minus j. I minus is because the current I. We have an I. Right? I minus, same thing, j and 0. Okay, so this now we go back to this method, right? We have this. That's not right. It's j minus. Oh yeah, it's j minus. My bad. Dude, this is j minus I. This is j minus I. Same thing here. This should be j minus I, right? This is j minus I. Interestingly, yeah, I always use the same word. Interestingly, we say current j minus 1, okay, equal to pre j minus 1 plus pre j minus 2 plus plus pre maximum. That would be j minus 1 minus I minus 1 of this and 0. Hence, current j shall equal to pre-j minus, so we can this minus this, right? This minus this. We can say this minus current j minus 1, right, is equal to, why did you delete it? Pre-j right, pre-j, and then these just cancel, minus pre maximum j minus 1 minus I minus 1, 0. Yeah. Right. And this one will get current j equal to current j minus 1 plus pre-j minus pre max j minus 1 minus I minus 1, 0. That is what we have reached here, right? Current j equal to current this plus this minus this. Yes. Now things starts to make sense. Okay. All right, let's do this. So we have n and k, right? So what we need is a pre. So pre will always equal to 0 because we have to count k, so we're always plus k. And 0 is always equal to 1. Right, 0 is always equal to 1 because if you have 0 pairs, you can always do it. So that's starting from I equal to, yeah, you gotta wait a little bit, but it's getting closer. So for I in range, because I did 1, so it will be 2 to n, right? Then we say we have a current, right? Current, same thing. We start with this. I think I have an extra character here. Again, still will be 1 plus k. Okay. Then we say, and for j in range, from 1 all the way to 1 plus k. That makes sense. Okay, then we just say current j, right, shall equal to current j minus 1 plus pre j minus pre max j minus 1 minus I minus 1 0. So current j equal to this. We go through everything, and at the end pre will equal to current, and at the end we'll return pre minus 1. Let's try this. 27. Ugh! What the hell? Wait, which part I did wrong? Oh, that part. That part. Okay, so the part is here. Yeah, because j minus 1. This is fine at the current, but this, if they're equal, yeah, what if j minus 1 is equal to 0, right? Yep, that's true. So we shall be this. If j minus 1 is larger or equal to I minus 1, else shall be 0. Actually, I think maybe it should be the same for... It shouldn't be the same for this one as well. J, if it's larger, we do this. If it's smaller, we do 0. I feel it should be the same for both, right? But it's fine because it's this minus this, and this will always be handled here because this. But isn't that the same? Huh. Yeah, I feel these two shall be the same. I'm just saying, like in this case, yeah, why these two are not the same, right? Why these two are not the same? I feel these two shall be the same. Then you do the minus these things. Then you will definitely have at the end is this. So minus. So, ugh. Yank this. Once you paste it, it doesn't. Something you yank it and you paste it. Yeah, actually, I still need to think more about this one, but I'll just call it for now. I still feel weird. I still feel weird that it has to be this way. No? Oh, wait a second. That is K. I mean, I do have the mod. Wait, what did I do wrong? Oh, I forgot. My bad. 0 is equal to 1. Yeah, and I will also have the mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I don't need this. Oh, I forgot to do this. Then maybe I don't have to use this one. Ah. Oh, it was, I think, I think it's right. Just the pre. Okay. Maximum j minus 1 minus I minus 1 and 0. No. No, because you're minus more than you should. Right, you're minus more than you should. Yeah, it should be. We ending at here, right? We ending at this is 0, but if this is negative, we just do 0. That does make sense. Ugh. All right, that should be it. Come on. Let's just copy and paste this. Yeah, I need to do this one more time. I feel a little bit rushed today. Time is a factor. Okay, just let it go. But yeah, this one requires some more attention. I'll put it somewhere in here. But finally, I think I can move on. Damn, I can move on to the new problem. Oh, awful. All right, that will be it. No, I do not have a baby. I have 2 cats, no baby. All right, that will be it. And I'll take a look at your resume. I'll see you guys tomorrow. Adios.